Like Jim's talking about compressions.
Okay, so for a long time, MicroPython has supported compression. Okay, so we have the zlib, import zlib, and zlib from Python inherits the decompress method. So you can pass in, so if I generate something from CPython, import zlib, zlib.compress. If I paste that in, I can decompress byte streams, and the byte streams can either be in any of the three deflate formats. So what's going on here is that the compression format is deflate, which is LZ77 combined with Huffman coding. And on its own, that's just raw deflate. And then you can optionally add either a zlib header or a Gzip header. And when you add zlib or Gzip headers, you also get a footer with a checksum. So these formats are pretty basic, but obviously very effective at compressing single files. In addition to what CPython supports, so if we look at zlib, CPython supports this compress obj, decompress obj, I should say, which provides a way, instead of having to have your entire data stream available in a bytes or byte array up front, you can provide it with a chunk of data at a time, and then it returns you back the compressed data as you go. And unfortunately, this isn't a terribly useful API for MicroPython, because typically what you want to do with decompression or compression is wrap it around an existing stream or file or socket or whatever. So for example, if you were writing web server and you wanted to compress data for your response, ideally you would just wrap your socket in a compressed socket and write to it. But these in Python, these compression objects are not streams. And similarly, if I'm decompressing a file, like it would be great to just be able to open the file using open, pass it into a decompress obj, and read from the file as normal. But unfortunately, the decompress obj, the way it works is that you push data into it by calling decompress, which returns the data. You don't read from it and it doesn't have an underlying wrapped stream. So I'm bringing this up because MicroPython for a long time has also had a MicroPython specific extension to the zlib module. What's going on? All of my boards are flashed with second button. Here we go. So we have this decomp.io class, and decomp.io is named in the style of, for example, io.string.io or io.bytes.io, which is a wrapper that provides a stream interface. And so decomp.io works like the decompress method, except it wraps a stream, and when you read from the decomp.io stream, it reads from the underlying stream and decompresses as you go. But this is unfortunately a MicroPython specific extension, and we are going forward aiming to do less and less MicroPython specific extensions, in particular in modules that have the same name of real CPython modules. So for example, because zlib is a real CPython module, standard CPython standard library module, it shouldn't have a MicroPython specific class in it. So we looked at what the other options were in CPython, and one thing that comes very close.
Maybe you can zoom in the font on that Firefox
browser.
Yeah.
CPython also has support for Gzip files. Now, the zlib module that we were just looking at, input zlib.compress, decompress, I should say. when I decompress data, I can optionally specify the W bits parameter, which I will show you here. So to decompress, I can specify this W bits parameter. And so although this is the zlib module, by various combinations, by various values of W bits that are either negative or positive between this range, or positive between this range, or positive in this range, it also handles raw and Gzip format data. It's kind of a weird API that zlib provides. However, they also provide this Gzip file, which is exactly like our decomp.io class, except it doesn't provide a way to configure the wbits parameter, or in any other way configure it to do anything other than parse Gzip files. So this is very, very close to what we want. And in fact, the pull request I sent yesterday does exactly that. What I did was I added a Gzip file, gzip.gzip file, that takes an additional wbits parameter and makes Gzip file otherwise behave exactly like zlib.compress, but through a streaming interface. And unlike this decompress obj provided by the zlib module, Gzip file does exactly what you want. It's a stream wrapper. You pass in the stream in this file obj parameter. And it's kind of neat. What you can do is write, for example, import Gzip with open /temp/foo dot. Actually, what I do import. I could write a dictionary. F with gzip file as G. This is not going to work. JSON.dump config. This is going to fail because the config is going to be written in text format and it's a binary file. But roughly, you can make this work. And it's quite neat because you never actually had to ever have any of the full data set, the full file or the full compressed file in memory, because the JSON dump will be byte at a time into the, I should have passed G as the extra parameter to JSON.dump. JSON generates the JSON byte at a time, writes it into the compressed Gzip file, which then wraps the underlying stream and writes byte at a time into the stream. So it's quite memory efficient and useful. And you can do the same thing in reverse if you wanted to read a JSON file using JSON.load. But unfortunately, if we were going to provide this Gzip file, we would then want to remove the zlib module because we're kind of duplicating the functionality. There's no point wasting the code space having two different ways of doing the same thing. But there's no CPython's way of then making Gzip files support zlib and raw formats. The other problem is that Gzip files are always compressed with really large windows, 32 kilobyte windows. And so in order to decompress a Gzip file, you must have at least 32K of RAM free to handle the biggest possible back reference that the file might contain. And it's fine to generate a Gzip file that doesn't contain back references that far, but if you're parsing an arbitrary Gzip file, you need to be prepared for that possibility. So Gzip files also got this kind of awkward thing of that you may not ever actually be able to decompress a given Gzip file on MicroPython because you may not ever be able to allocate that much memory. So Gzip file is not quite the API we want to provide, unfortunately. So the decision we've made is that we're going to make a new module called deflate, and deflate is going to have deflate.io, which is kind of the successor to the old decomp.io, but it's supporting compression and decompression, and it will have similar functionality to Gzip file, allow you to read and write raw, zlib, and Gzip streams, and configure the window size. And also something you can't do anywhere in regular Python is it will let you configure the, you'll pass the history buffer as a separate parameter. So you can reuse a history buffer between multiple compressions. So if you've got to compress like 3 different files, you can allocate history buffer once, and then you don't have to worry about memory fragmentation because of the additional allocations. Sorry, that was all a bit disjointed all over the place. I was planning to have a little bit more time to organize my thoughts, but maybe the best thing is if people have questions. I can give a demo of this working if you're interested, but the demo I'm going to give you is what I had implemented earlier today, which is Gzip file with these extensions. But what we're going to make it actually is a new class and a new module. And the demo would give you is exactly what regular Python Gzip file does. The only other thing I wanted to talk about is kind of in this area. We've been talking a lot about Python compatibility in the last couple of years, but also more in the last couple of months. And so a couple of other things that have changed in MicroPython recently is that we've been renaming the built-in modules to match the CPython names and not have the U prefix anymore. So something that will be in the next release, but has been in the nightlies for a couple of weeks now, is that if you do help modules, the modules are actually called IO and JSON and SSL, not what they were before, which was UIO, USSL, and UJSON. And similarly, async IO is now just called async IO. So I guess just using this as a bit of a public service announcement that from now on you can do import async IO instead of what you had to do before, which was from import uasync IO as async IO. So you don't have to do that anymore. Just write import async IO. And I kind of alluded to this earlier. This is something we're going to start to do more of, which is not do when we're implementing CPython functionality, we're going to make it match CPython functionality and no longer do custom extensions or modifications to things in CPython modules. Of course, the thing that a lot of you are probably thinking is, for example, import time. We have time.tix MS and stuff like that. So there's going to be a lot of things historically that are still like that. But over time, we'll look for ways to either rehome them or no, the main thing here is that we're just not going to do any more of that. And yes, probably best answer if you have questions, I can answer them.
It might be worth pointing out that the reason for all of this is to implement compression.
Oh yeah, sorry. Yes, that was the headline thing that I was talking about, which is compression. Yeah. So the key thing is that Gzip file, which is what started this approach. Gzip file, once you wrap a stream, you can either read or write to the Gzip file. And if you write to the Gzip file, then it's compressing and outputting to the stream. But if you read from the Gzip file, you are reading compressed data, and then well, you're reading compressed data from the stream such that you get decompressed data from the Gzip file. So the long and short of this is that very soon in MicroPython, you'll be able to go import deflate. No, not at this build. Pretend I did file as deflate. So like I said, I was in the middle of oh no, the wrong terminal. But what that will be soon is from deflate, import deflate.io, and then you'll be able to do say the demo I gave before, which is you can use deflate.io to wrap a stream and read and write compressed data from it. So for example, so I'm open the file for writing, so the writable stream. So this will change in this API here will change in the final version of deflate.io, but that's the rough idea. And then if I do g.write, MicroPython, g.close, f.close, and these support the with statement as well, of course. And then now on my PC, yep, if I do so in MicroPython, the Unix supported MicroPython, I created a deflate IO wrapper around a writable file. I set the window size to 512 bytes. That's this API will change, but that's currently matching how zlib does it. It's a writable Gzip deflate stream. I'm writing decompressed data, i.e. my original data, to the stream, and equivalently I could have passed that to you know, if this was my HTTP server, this could just be my socket that I'm writing to or whatever. You could further wrap that in an SSL using SSL wrap socket, and that wrote to the underlying file, close the Gzip stream, close the file, and then because it's the Unix port, it can access my real file system, and then now I can pipe that file out to zlib decompress, and you can see it printed out MicroPython, which was the which is what I wrote as the compressed data. But if I look at Gz, you can see it was actually the compressed. That's the zlib header and so forth. And similarly, I could have written, if I'd set the wbits parameter to something different, I could have put it into Gzip mode, for example. Now, the way this is actually going to work in the final version is that the deflate IO constructor will be, that line would be g equals deflate IO, wrapping the stream, the file, and then it's going to be format equals deflate IO dot, say, Gzip. And then optionally, you can specify the window size based on how much RAM you have. But the same idea as what we just did there. And for reading, if it was a readable file, then you don't specify the format at all, and it can infer the format from the stream, and then you do g.read to read decompressed data, or you could do JSON.load from G, for example, to decompress a JSON dictionary from the compressed string. Cool. All right. Does anyone have any questions about that?
Very good. But if it's in raw deflate mode, I guess you have to specify that, because it can't.
Well, to be decided. But a raw stream is neither a Gzip stream nor a zlib stream. But yeah, we could also make that explicit. Yeah.
Mm.
What's the speed like, Jim? Have you done any benchmark?
That's a difficult question to answer because I don't have a reference on the microcontroller, but it would be worthwhile doing a performance comparison to, say, zlib on the PC. So there's a couple of points here about the speed. The compressor, now, when you're generating deflate compressed data, there are kind of two parts of this. One is managing the Huffman table, and the second is finding the references back in the stream. So, so the whole point is that you're doing compression by saying that this bit that I'm about to emit is the same as something that came earlier, and that's why you have this window, so that you can say you can keep track of what you emitted earlier. Now, doing that efficiently and well, doing it both effectively and efficiently requires using a lot of RAM, not just for remembering what you already emitted, but also having an efficient way to look up that history. So something like zlib uses a hash table of previous tokens and so forth. So our compressor, in order to reduce the amount of memory it uses, doesn't do that. Damien's implemented a very, very tiny and very, very memory efficient compressor, but it does mean that it is doing ON linear searches in the history to find the matches rather than doing a hash table lookup. So it will be, for compression, it will be slower. That said, for a lot of purposes, you still get quite good compression with small windows. And when the window size is small, doing the linear search isn't terrible. For decompression, as for code size, something like zlib uses a bunch of lookup tables, whereas we compute the values in those lookup tables. So yeah, so decompression is fast, but it's not as fast. I will try and get some performance benchmarks into the pull request once all the work's done. But, yeah, it's also getting reliable performance benchmarks is can be a bit tricky, but I'll because the problem here is it depends a lot. The results are very different depending on the size of the streams and the type of data in the stream. So I'll try and generate a bunch of different streams of different types with different sort of compression properties and get you some numbers.
Yeah, no, that's interesting. Thanks. So yeah, I guess the microprocessor is going to make a huge difference, isn't it? Depending on the platform.
What I was sort of alluding to here is that this is the sort of thing that performs very, very differently on a desktop CPU compared to a microcontroller CPU. You know, all of the things that make desktop CPUs fast, you know, enormous caches and all that sort of stuff, and would make it will be harder to predict the microcontroller performance. I did an experiment where I did it before I changed it to use before I replaced all the lookup tables with computation. The performance of decompress. Sorry, let me say that again. I started with the version that we had that didn't use lookup tables, and then I changed to use lookup tables. And on Linux, the performance decreased by about 20%. On PyBoard, I got down to the millisecond. It was like 4,000 and something milliseconds, and I did it again, and I got exactly the same number again, which was almost unbelievable. But on the microcontroller, the performance results are repeatable, so you could just run the same test over and over again and get the same results in a second. So it made no difference, which was quite surprising. And so yeah, my point there is that I'll get performance numbers, but they may not be representative for what that means on a microcontroller.
Cool, thanks.
The detail there with the module renaming is that the purpose of one of the purposes of having the U prefix on the modules was a way to force importing the built-in module. So in MicroPython here, for example, if I have well, this is not going to work anymore. Well, actually, if I do import OS, I get no longer the built-in one. I get os.py from the file system. So we still support import UOS in order to get the built-in one. So and do uos.urandom, for example. And this is really important for being able to extend built-in modules from Python. So what you can do is you can write an os.py that imports UOS to add additional functionality built on the functionality built in the existing one. And what's changed here is that this mechanism of being able to import from the file system or from the built-in, possibly, is still the same. What has changed is that the module UOS is actually called OS now, which is why help modules lists the real names rather than the U prefix names. In addition to that, we've made Sys.path work with us. We've slightly changed the behavior of Sys.path. So it used to be, and this is kind of useful, unrelated to the built-in module stuff, which is that you didn't used to be able to assign to Sys.path. You always had to either append or push or pop or clear. You couldn't go my new path or whatever. Now you can. And in addition to that, you can set Sys.path to the empty list or the empty tuple, which now removes the file system from the imports, and now you can force a built-in like this as well. So so I no longer have a Sys.path. I've saved the old Sys.path in this variable A. If I do import OS now, I don't get os.py as I did before. I get the built-in OS. So os.urandom again, for example. And if I want to now force, even though I've imported OS, if I want to now force the built-in one, oh, sorry, that's how I force the built-in one. But yeah, this is it's a slightly more flexible way of working with Sys.path. It occasionally used to be frustrating that you couldn't do, for example, if you had your own completely custom path that you wanted to set, you had to do something a bit awkward like Sys.path equals my path. And the underlying issue there is that Sys.path, Sys was not mutable. You couldn't replace the path variable in Sys. You could only modify Sys.path itself. But now the Sys.path attribute, on the Sys.path attribute on the Sys module is now completely mutable. Cool. Sorry, that was all a bit disjointed and all over the place. I was not quite as organized as I'd like to be.
That's fine, Jim. That's good. It's also good to have you back at the meetups. I know you've not been able to make it the last couple of years.
Yeah, I'm not sure how regularly I'm about to do this.
I understand. It's okay.
The other thing I should ask, a good group to ask this to, is we are considering what configurations we should enable compression on. So decompression has been enabled for a long time on most ports and boards. Like almost every board that we support supports compression. It's using what we call the extra features level. So that includes like STM32, RP2, ESP32, ESP86. And what we need to decide is, should compression support just be added as well to all things that currently support decompression? Should we only support it on boards that have more flash, which is what we call the full features configuration levels? That would be like RP2, ESP32 with big flash, the bigger STM32 boards like PyBoard D or whatever. Or should we just not enable it at all? Like, is compression a useful enough feature that it's worth including in the standard firmware? And if people want compression, then they can build their own firmware or make their own board definition or whatever. So I would actually be quite interested in people's thoughts on that. Is there anyone here in this meeting that was like, yay, I'm going to use compression tomorrow, or could imagine using compression in their project?
Well, yeah, I mean, obviously,
yeah,
not that obviously, but yeah, at work we've had to use it, so it's a welcome feature.
Yeah,
we could
but
also.
But you're a great example. You build your own custom board definition, so
exactly
the points. That's
it's a bit mood. Yeah. I don't think people are excited about compression.
Yeah, which is fair. Kind of one of the other thoughts I have about compression is that maybe there just isn't that much need for general purpose compression on an embedded device. Like, if you're working with real-time data streams, you'd be mad to use deflate, because you might get some compression, but you'll get a much better result from something that is tailored more specifically to your particular data stream. Maybe we want to look into other options for some sort of like boxcar compression or something for real-time data or something like that. And yeah, so maybe this is a feature that isn't worth enabling by default on any configuration.
Were you asking just about the 32K?
Things are Gzip, and often they mean the default's in 32K. Like most websites.
Can you hear this, Jim, by the way?
No, I can't hear that.
Right, come over here and scroll, Adrian.
There's a message in chat.
Yeah, Patrick's.
I'm just thinking about websites. Like if this is a use case for this is websites where you get a stream of Gzip data that's using that 32K. I mean, does that default to 32K?
Exactly. So this is the problem.
So if most websites give you the 32K requirement, how useful is that going to be on a microcontroller?
Well, yeah. So for one thing, that's decompression. So we do already support the decompression, but it's a really good point. Like our existing decompression support is potentially not that useful in an HTTP client, because you may not be able to decompress a given stream. And the way this works is you don't know if you can't decompress it until it tries to do a reference far enough back that you don't have the history for it. So it'll fail decompression midway through the stream. So it's not like you can say, oh, well, okay, well, now I'll just allocate a bigger buffer. You sort of speculatively allocate, because at that point you've already thrown away the history that you would have needed to satisfy that back reference. So yeah, there is not a good solution to this. Gzip files have 32 kilobyte windows, and
that's often the common setting, is it?
There's
a feature that it can change.
You can change it. If you look in CPython, for example, you can't change it if you use Gzip file. So either Gzip file to open or Gzip file directly, you cannot configure the window size. It uses a 32 kilobyte window size unconditionally. If you use the slightly awkward zlib.compress, where you pass in a value between 25 and 31, 31 is what Gzip file uses, but you can turn it all the way down to 25, which corresponds to a 512 byte window size. So it is possible to produce a Gzip stream that has a small window, but nobody does this. I think is kind of the point, unless it's you that runs the website, and if you run the website or the web service or whatever that your embedded device is talking to, then yeah, absolutely, you could, if you control both ends. But awkwardly, you can't use the streaming interface, for example, in Python if you're running the website in Python. Of course, if you're using zlib directly in C or something, I've not looked at what other languages do. But if you're just using your web server's built-in, is it mod compress in Apache, whatever, I don't know, but I don't know if you can configure it in I've not looked in
Probably can configure it, but whoever does that,
I don't see it in here. Yeah, I don't see it in here. So
I think it'd be key to have some clear documentation around this too, Jim, like some indications as to where
and in fact
common use cases.
The request already wrote a couple of paragraphs on this exact point, but yeah. So the point is that if you're controlling both ends, like it's your web service and it's your embedded device downloading from it and decompressing from it, then that's great. And in particular, I'd recommend you probably use zlib. One advantage of zlib rather than Gzip compression is that the zlib header tells the receiving end how big the window size needs to be. So you can decompress a zlib stream without needing to know whereas you have to assume that it's going to be up to 32K. On the other hand, for specifically the point of compression in MicroPython, we can choose any window size we like. So for example, it is valid to create a Gzip stream with a 16-byte window, which would be mad, but you could, and that would be perfectly valid and readable by any Gzip decompressor. So if you were writing a MicroPython web server and you wanted to do Gzip responses, then that's totally fine. That works. You would just choose a reasonable window size, like 256 bytes or whatever.
Yeah, cool. Okay. Having gotten a glimpse of some of the implementations here, yeah, I'm really impressed by your dedication to get all this done, because I know it's very difficult getting all this working and balancing all the different trade-offs in a very resource-constrained environment. So
thanks. It's been there's lots of funny little details, like, so when you compress, so initially when I was trying to exactly match the Python API, compress allows you to set the window size from 9 to 15, corresponding to 512 to 32K, but decompress lets you go from 8 to 15. So there's all these funny little edge cases. And then it turns out secretly Python actually allows you to compress with 8, but but it pretends it's actually 9, and there's all these little details and stuff like that. But yeah, no, and thank you to Damien for implementing the actual LZ77 compressor that this all uses as well.
it's also a feature that's not that exciting to think about, but geez, when you need it, you really do need it.
Yeah, it's difficult. And I should call out those. I think it's Brian in the Discord who implemented a compression algorithm. I think it was their own algorithm, but they implemented it using Viper entirely in MicroPython. So yeah, there's definitely that was a challenge, right? So there's definitely advantages to being able to do this in C and build it into the firmware and just have it ready when you need it. But yeah. Well, if anyone has any feedback on whether or not they think this should be enabled by default, or probably more importantly, if you think it should not be enabled by default and would rather we spent the firmware size on other features, please let us know on the pull request.
Cool. Thank you, Jim. Thank you.
All right.
Appreciate that.
Cool. Thank you, Matt.